Hi, let's practice finding the equivalent resistance of a simple circuit. So here's an example. I know simple is in the eye of the beholder. This one might look a little messy, but chunk by chunk, it's very manageable. Let's start by looking for shorted resistors. If a wire touches both ends of the resistor, nearly all of the current will move through the wire rather than the resistor. That's the easiest path. Do you see a wire that's shorted out? Hopefully you said, yes, the 2.7 ohm resistor. Awesome! We can ignore it in our analysis. Next, just for fun, are there any resistors in series? Series means the same current runs through both, or all of them. The 7.8 and the 3.3 ohm resistors may not be hooked end to end, but they are in series. The total current moves through each. These are the only two in series. Are there parallel sections that we can simplify right at the start? Two sections should leap out at you, the 8 and 12 ohm pair and the trio 3, 4, 6. Using the parallel resistance relationship, 1 over 8 plus 1 over 12 equals 1 over the equivalent resistance of the pair. Don't forget that the sum is 1 over the resistance. Flip the sum to get R, 4.8 ohms. As for the trio, 1 over 3 plus 1 over 4 plus 1 over 6 gives 1 over the resistance we want. Flip the sum to get 4/3. The current running through the 1 ohm resistor at the top splits between two branches. Branch 1 has a 4 and a 4/3 in series, so add to get 16/3. Branch 2 has 4.8 and 3.2 in series, so add to get 8. These two branches are in parallel. 1 over 8 plus the reciprocal of 16/3, so 3 over 16, gives 1 over the resistance we want. Flipping, we get 3.2 ohms. The current from the 7.8 ohm resistor splits. Part goes through branch 3, a 21 ohm resistor. Part goes through branch 4, a 1 and a 3.2 in series, so 4.2 ohms. These two branches are in parallel, so 1 over 21 plus 5 over 21 gives 1 over R. Flip, and we have R for that whole mess is 3.5 ohms. Only one task left. The 7.8 and 3.3 are connected in series to the 3.5. Add them all up, and we have the equivalent resistance of the whole shebang. Holy moly, that mess can be replaced by a 14.6 ohm resistor. Now, we can calculate the current provided by the battery for a given voltage. We could find currents and voltage drops for different parts of the circuit, etc., etc., etc. That's all for now, folks.